hi again. A toolkit is very useful if you can't make plugins with it, so I prepared a little minimal plugin here to both to explain what's needed in a plugin and to see if it actually worked in practice and just not in theory. So what I did was make this typical game plugin. That's typical hello world of plugins kind of stuff. It just when we have one parameter that can control the volume or passing audio. I saved it here in under the plugins test directory, and I will upload to GitHub afterwards, so you can copy it and look at it if you need or want. So a plugin, a full plugin here, needs 4 lines. That means 4 parts to function. It needs a descriptor, it needs a processor, it needs a plugin class, and it needs the entry point. The first one, and some includes, of course, this kind of drags in everything, more or less, and then you need, we're making a plugin, and we need a block processor, so we just include what we need, nothing else to link in and anything. So so the descriptor is the part that tells the host a little bit more about our plugin, about what category, type of plugin it is, what the name of it, and the ID and that kind of stuff. And it reads, this is what the host reads before creating any instances of your plugin. So it is actually just a bunch of text lines. That's a clap part. I'm using the clap directly here. I don't have an abstraction or anything, because I mentioned it before, but the entire toolkit is based on clap. Clap is the thing in the core. You're always making a clap file, no matter if you compile to a VST3, for example. The bottom is a clap file, and then I have a bunch of utilities and helpers and abstractions to simplify it, and not hide it directly, but to simplify it. And then there's some wrappers on top to in and out from the other wrappers, other types, including the internal hosting for executables. But the descriptor, this is just a descriptor, the static structure, and you just fill in the variables here. The important ones are the ID. That's the part that uniquely identifies this plugin, and it's, as you can see, just a text string. I know the clap people, you wanted to use this this inverse web stuff, company.ets or something, but it's just a text file, a text string. So you can, but we make sure it's unique, that it's so that the version 2, for example, if you want it to be the similar updated version, you need to keep it similar. If you make a new plugin, it has to be different. So this is uniquely an identifier. The name is what is written on the host writes in its list of available plugins and that kind of stuff. For example, if you want to instantiate a plugin on a track, it gives you a list of plugins, and that's the name it writes. So, and the other thing is that you can do the same thing for vendor. It's the same thing as a plugin author, but I have some defined, so I don't write this often because of laziness. Same URL is meant for I don't know. I don't think any host is looking at this at all, but I've probably meant for like so. And here's more URLs: manual and support URLs. So probably some manual automatic setup about screen or something. Maybe the host could use this. The version, I set it again the same version as the toolkit itself. Yes, it's probably not a good thing, but again, this is also a text string. So you could call it anything, but it probably should follow the standard format. Description is a text string. This is a massively cool plugin. The description. A host usually or sometimes writes together with the plugin name and that kind of stuff. So you could maybe write it the reverb plugin, or you could make it a stereo effect, blah 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 blah. I don't know. This we'll see later if Bitwig is printing something. And this feature stinger is a bit important. As you can see, it's a string of text. It's again an array of text strings, so you can have multiple of them, and it has to end with null pointer. That's the. But in this case, we just set to audio effect to tell the host that we are actually an audio effect and not an instrument or a note effect or whatever. There's a bunch of other things you could set it up in defining clap, but here's the main ones: instrument, audio effect, note detector, and analyzer. Depending on audio inputs and outputs, and note inputs and outputs probably, and analyzer if you, I don't know. But anyway, that's the descriptor. As you can see, it's a bunch of strings only, mostly, except this version here. Then after we have the descriptor, we actually need a plugin, but let's go to the, yes, can I take a plugin first? A plugin is very simple. It's based on this SAT plugin, which do 99% of the generic things you usually use. Like it takes care of the parameter values and tells a potential GUI about it and all that housekeeping stuff. It does that in the background. But you just override the functionality that you need to add your things to it. So if you don't do anything in it, it will still. I can show you afterwards. If you can still get rid of everything, and it still would be a valid clap plugin, but it wouldn't have audio inputs and outputs. Okay, now I'm talking a bit. Maybe take line by line instead. Let's say we can be back to the plugin. We inherit from the plugin, SAT plugin. This we need some private variables, especially this processor, which is here. I'm going to explain afterwards now. That's the only thing we need actually here, because the processor contains most other things. And forget this. This is another thing I haven't copied from the previous version. It was getting tedious to always write the same constructor over and over again, because you have to pass some variables and stuff, arguments to it, to the plugin, so you can't just skip it. It will complain. So I made this macro that just hides all this into a and do it for you. But that's not. I haven't. As I said, I haven't ported or copied it back yet, because I haven't needed it. But this is a very simple constructor destructor. As you see, it does nothing. It just passes it on the descriptor and the host to the plugin. Here you could take, these are always available in some other methods, so there's no point in saving them here, unless you think that is simpler or something. So this is just a generic. You have to include it, unfortunately, unless I add in this stuff and minimize it a bit. But here, this one in the function, and you override it. It's very important. This sets up your almost entire plugin, everything, and then after this one has been after you return, everything should be just almost like switch it on, and it should work. All the parameters and all the ports and the processing and everything. So try to minimize it so that it's not heaps and heaps and heaps of text lines to set everything up. So there's layers and layers of minimization and simplification going on in the background. So it's starting to get. I think this is bearable. It's not too much. We have to set up a few things anyway. So in clap is a bit different than VST and all that, the other formats, because almost everything is an extension, except processing. You have to process something. But even parameters and the state of the plugin and everything, all that is a extension. So you have to set up or kind of decide or support the needed extension. And that is what this single line is doing. It sets internally. It sets up just a list of sets up what extension when the host is asked. ask the plugin about what extension we will support, and this kind of take care of the normal ones, which is just a 3 or 4, I think. Let's see. Yes, it registers the audio ports because we need audio input and output. And if you haven't defined this one, which actually this actually sets up a define so that this is not this. We don't have a GUI if you say no GUI. So in this case, we are not using a GUI, so this one is not included. But we are setting up audio ports, parameters, and state. And here again, you see the direct. This is clap specific. This extension stuff is clap specific, and since we are very clap based, I haven't even mattered about hiding that fact. It is a clap world. so that's, we set up these ports, param state. From here, we did this. We could also have a bunch of, as you said, all functions. You could register all extensions, or you could register single ones yourself, just similar to this. Or you have another one for synth extensions, but I have to work more on the voice stuff to get that ported over to a new version. And there are some changes probably to. But anyway, we have extensions. Now the hosts know that we have an audio input and output, and we have state, and we have parameters. And now that we have told the host that we have audio ports, we also need to set up the ports. And the 2 lines here is a simplification again, sets up that stereo input and stereo output for us. There's a bunch of other ones, the different append the audio input, stereo variations of this, depending on how you define your audio ports. You could define a class here, and you could define this as just a port info, and different ways. Same thing with the note info later, or note ports later when you create a synth. And here is an important thing: the processor. This is the part that processes or takes care of or handles both the audio processing and the event processing, and how they are interleaved and how they are processed. So you actually create a processor and just give everything to it. You give here's audio, here's video, do stuff, and then it doesn't do it for you, kind of stuff. Vaguely. We create it very simply. We have to tell it about ourselves or the plugin, so that it knows how to kind of tell us back a few times. Especially I think it on, if I remember correctly, it only uses this to get hold of the host here, so that you can tell the host, for example, when a note ends and parameter changes and stuff. If I remember correctly, so it just reads off some pointers. Then we have to tell the plugin, or actually the system, the toolkit, that we're using this processor. We could set up a bunch of them and switch between them, for example. Where we do want sample accurate events or not. And then we are creating a parameter, and we are doing it in one go here. We are just appending it first. We are creating it inside here. Let me see. This here. We are creating a parameter class because that makes it easy. A bunch of default values, but I filled it out just to show what you can do, or what is possible. This is the name of the parameter, and this is the module, which is mean like say you could have filter settings, LFO settings, global settings, that kind of headlines, and some hosts might sort your parameters under these kind of headers and maybe make them collapsible, for example, and that kind of stuff. But I don't think any host is, at the moment there's not too many clap hosts yet, unfortunately. But this will probably be not important, but ignore it for now. That's the module. They call it a module, but I see, you can see grouping maybe or something. The first value here is the default value, with the value it starts with, and the default, and this is a minimal, and maximum value, and this is a bunch of flags. At the main moment we are very minimal, and just set it automatable. Automatable actually means that the host can change it. If you don't have this automatable, I don't think you will ever get parameter events even if you turn the knobs on the host GUI or anything. So this is important. This I forgot this a couple of times, and you wonder what the F is happening. So this is, hey, okay, nice. I didn't know that in code, which I'm using, Visual Studio Code. If I just hold this helper, oh, that is nice. And it said automation can be recorded, automation can be playback. There are also a bunch of others of stuff if is available. Modulation is good. That is really nice, but that's more for synthesizers with multiple voices. Periodic and that step can be important if you have int steps 1, 2, 3, 4, and enum maybe if you have, for example, a text box with 5 choices, it may be an enum. So like from 0 to 4 would be more suitable. But then I have also a bunch of parameter types at the moment, or this parameter is a base class, and I have let's see, but I'm only using the int and text at the moment. I'll use now we only use the basic parameter. And after we have set up everything, and this is not everything, the thing we need to set up, we call back, we return back to the plugin default to how then the plugin function class itself will start using this and set it up a bit further and process pre-process things, and you make things ready for, so the host gets the right info when it asks for it and that kind of stuff. That's actually all. And one thing, of course, if you need a sample rate is the first time sample rate is given to you is the activate process, which is a function. So if you need it, you also have to override the activate function. You see that I call it final. And then, for example, remember it. I usually have this. I just create a set sample rate in my processor here, and just call it to give it sample rate, for example, and then call back. This is important. This needs to be documented, I think. A bunch of these functions have what I call default handling or managing, and it does something. So if you override them and don't call back into them, there might be something that is not happening that you expect happening. For example, parameters sent over to the GUI and that kind of stuff. So that should be it's safest probably to always call it, especially things in the plugin function. I know it needs to be documented because it's a bunch of stuff that is actually meant to not call back because you're actually taking over things, but we need to look a little bit detail into that part. But anyway, but let's say we don't need a non-linear sample rate at the moment because we are just using a simple gain plugin, which means this is the entire plugin. You need actually this part here is actually the entire plugin. This is what it does here. But this part is gain processor part is, since it's actually doing more than a plugin almost in this part here, which but still quite simple. It's just a processor. A processor is, as I mentioned, a class that does all the processing simply. It's a few functions and stuff, of course, that you can override. Let me see. Maybe I should look into it. Okay, it's called from processor again. It has all of these functions to get events. So you could, every time the system or in the processing function internally gets an event, or the GUI or anything of that, these functions. So you override whatever you need. If you need to listen to note-on events, you just override it and just do whatever. And these are all the events. Let's see, there's notes on and off. There's choke, the same as note off, but die instead of fade out. And for like the drum synths usually. Expression is nice for note expression like pitching and all kind of stuff. Parameter value event, that is where you get the parameters from. And modulation events is separate to parameters. Transport is for play and stop and start and stuff. MIDI if you really need, and told host that to support pure MIDI 1 or MIDI 2. I don't think many hosts support MIDI 2 yet, but anyway. So the absolutely simplest thing is just to, as you said here, override just a parent value event to get the parameters. But then more or less the same thing with audio processing, and also you could do, of course, drill into this and override at other levels, because there's a couple of 2-3 steps of processing until it reaches these events. Maybe you want to process all events in one go, for example yourself, for example. Then you don't and you don't want all the potential overhead, or you want to do something else. Here I had something else earlier, or something maybe you want to do something with. For example, I don't know. The easiest to start with is just use this bang, and then you get there directly. Here's the note event, here's the note off, and then you can process them there. And then another thing is interesting is that those callbacks or functions are called when it happens. So that's why the processor has both the audio and event processing, because it do all this separation and calling process audio, process event, process audio at the correct positions for you. So you just react to this part kind of stuff. So that's why you don't need to care when a function is being called. You can just assume that it is being called when you have told at the right time, from the right place, from the right thread, etc. The audio part, the other part. Let's see, all of this is event stuff, a bunch of stuff, auto stuff, potentially transforming events from MIDI to, or translating maybe, to clap. Where are we? Here it start. Here's the the minimal sample. I'm going to explain it properly in a while. Process stereo sample. This is the simplest function. It will be called, as you see, several times during this processing area in all these different. Or you could go a step higher up as with the event and process all the audio. Or this is a chunk of audio in one go. You just override this function. You get called every time there's a chunk of audio to process, and without any events in between, so you just go through this buffer. That's the opposite. And then you have another place you can process audio, and then you take over the entire thing. But here, of course, is because the block process is overriding this. And let me see, this is internal. Then we have the block processor. Let me see where we are in the plugin. No, we are not in the processor. Block processor. Let's rearrange a bit here. We have an interleaved processor, and we have a quantized processor. We also have the beginnings of a few more, like voice processor, threaded and stuff. The block processor, this is the simplest one, which is inherits directly from this processor here, which is actually what we are using. It's doing things in a really old school way. It's just at the beginning of the audio block, it processes all the events. It doesn't care about timing. It just here, there, and then away in the entire buffer in one go. You could, for example, use it to kind of remember all the events, and when the audio is you are told to process the audio, you can do this event stuff yourself, for example. That's possible. Or maybe you have some other, you're calling some external library that expects that kind of thing. And it's very simple. It just, as you can see, it processes events and process audio, and not and finished. Ignore this. That's what we are using. There's also interleaved, which do a little bit more. As you can see, it goes through the buffer and split it for us at the event positions. So we will call, for example, first 5 samples, and then an event, then 17 samples, then an event, then 20, then 15 events, for example, etc. And finally, we have the quantized processor, which do it kind of the opposite way. It splits the event into regular chunks. I think it's set to 32 at the moment. And then for each slice or segment, it processes all the events that falls inside this segment, and then calls the audio processing to render the chunk. Then do the same thing, and the same thing all into the buffer is finished. I'm planning to do this for some optimization thing where the number where you can unroll a lot of loops and stuff. So I expect this quantized processor to be more efficient, more kind of an optimized things. But anyway, we are using the block processor. Now I'm talking again. Typical. I shouldn't plan to not get off track, but I can't. Anyway, so we're doing it very simple anyway. We use the block processor, since this is the simplest one, and here's some private variables to keep track of the value. We could I can and then again, stupidly the constructor and stuff. Maybe we don't need the structure actually. This is automatic, but the constructor needs because of this. We need to pass the owner. The owner is actually the plugin, so that the block now we could kind of almost. Let me see. But it does have a few functions like it get stuff, so you can cache it in the beginning and then and you need to talk back with the update parameter from host to GUI and that kind of stuff. So we need this constructor and destructor just to kind of set it up. And here's the param value event, the event from the block processor or processor with the parameter. And it's very simple. We just look at the param ID. That's the short for parameter ID. It's actually a 32-bit number, but I play a little bit old school at the moment. And use the parameter ID and index as the same thing. I have a bunch of, let's say if I have 5 parameters from 0, 1, 2, 3, 4, I use the parameter ID exactly, so they can point kind of to the same. So that I don't have to do a remapping in between. But that's an idea thing we could add later, because at the moment we can't rearrange. There is no the dynamic parameters. For example, adding a parameter and stuff is a bit problematic. So it's currently set up for static array of parameters that never change. But we can look into the remapping thing later. But anyway, what we do, it just reads that parameter ID and assume it's an index 0, because they are numbered in the order they are created here, or they are appended to the plugin. So we have just one, which we start of course from 0, so that's index 0. And we have this check. We don't really need it here because we are now, if we are called with other values here, the host has a big problem. But anyway, we do in case we have more, we just continue with more here. And here is just to read out the value. The value of the part of the event. The event has a bunch of stuff available. Cookies, I can't do this. I kind of actually points. No. Most of these are mostly meant for example, if you have polyphonic modulation and stuff and parameters, so you need a bunch of to separate them, a key and a node ID and stuff, and channel and stuff. But you need the value and the parameter ID. Actually, in the view, only thing we extract from it, right? And actually, we don't need to do that either. But we can later. We go first look at the process sampling, and as same thing as with the event, we do the simplified version, where we just, since we process stereo sample, we do it in not an old school way, but kind of stuff. This is a kind of a replace. You get pointers to left channel, right channel. That's pointed to one sample only. There's a buffer. There's single sample. So this is the left sample. This is the right sample, and then you do whatever you want with them and put them back, kind of stuff. So what I do here is just multiply them with our gain variable. So if I turn on the value, the values, the incoming audio will be reduced, and that will be sent out. The most simplest thing I could imagine. And that's it. That's the only thing we just need to remember the variable or the gain. So we have the amount of gain we want to process with, and then actually do process. So and then you can have different types. If you support modulation, you add the same kind of functionality or same kind of override. I mean, and etc. So it's very easy to get started, I think. And finally, we need one single thing, because now it's just classes in a header file and doesn't do anything. That's no use. It doesn't have anything to run it or use it, anything. So we need to tell the host about it. And here's what I have. This includes people who usually want it on the top, but I want to go. Who cares? I want it here to collect everything we want to. That doesn't really matter. That's optional and personal. Here's the again. I like to use macros to hide away. As you can see, it hides away a bunch of things that you don't really have to care about. And we're actually defining a couple of functions which use the descriptor and the class. These are the two classes we made up top here. I mean the descriptor is the descriptor here, and the class, of course, is the plugin class, and the class has the processor. So that's how they are related. That's it actually. This is a bit hairy maybe. You have to dig deeper into the internals to kind of see what all this is all about, because they have some global stuff with some registers. So I could have the point with this is to have multiple plugins inside a one clap file. So the setup or the macro here is going to hide that away if you have only one plugin. As you can see, it checks the index here. Because you can have a bunch of registered multiple descriptors, and they will be indexed by index, and it will be, you separate them in the create plugin here. So you could in theory copy this and use this instead of the macro here. Macro. And it will be the same thing, of course. And then you could start adding cases for different multiple plugins if you want to. That's actually almost simpler. But now if we can, that's the let's see if there's something I forgot to talk. The processing part, I know very what is it called on surface, superficial. Now I didn't deep, but you can go really deep looking into different processors and stuff and quantization stuff, but some of it is still in progress, and some of it is kind of semi-working, but maybe not finished. So this maybe I shouldn't dive too deep at the moment until things are more and more cast in stone about. And maybe I will make a few more examples that because stepwise more and more advanced, plus go into instruments then. But then again, I have to do this voice processor stuff, which at the moment it's just it's just a comment left out mostly. But anyway, let's try to compile it. So use our usual plug. Now I added in no GUI, and you see that we compile that. How long do it take? It takes, let's see, 0 point something. It takes half a second. And let's look into the binary. Just look at it. Interesting. There's it. Let's open it. Containing folder and plug. Oh, it's 500K. That's quite big, I think. So let's compile it. No, not a debug version. Remove the D. I took a whole second. And now it's 130. That's bearable. And now I have to tweak a little bit to be sure that it reads the newest version and it's updated. Let's see, let's also double. And now we can drag this. Let's say I have prepared. Oh, let me have here. Okay, I have this loop here. And now we can just drag and here it is. With a GIF working, and we can do all the normal things like modulate, but now there's no proper modulations. But as again, since as you can see, it's sending a modulation signal. But let me stop here. But then again, the plugin's working. Let me kill it. The reason why it didn't react to the modulation signal is because we didn't have a param mod event here. We can just as well. No, I don't want to go into that kind of details. There's one other functions that is kind of nice to know about is what is get what is it? Parameter value. And then we could use needs the index. We can just actually we don't need the entire thing here. We can just use this get gain equals to this kind of stuff. You can compile it, and then you can double check that it's actually working again. Or if you have to delete it here. But now I don't actually have to. Sure. The easiest way is actually to terminate process, because now it kills every process with the plugins in it. Which means it doesn't hang, it doesn't do all the caching stuff, and stuff is cleared. So when I activate it, it will double check and re-index and reset everything. So now I know that it is actually, no matter what, it's the newest version. Dragging in, and let's see if it actually still works. And it still works. Save it. Yes, so it still worked, which means the plugin example is even simpler. I mean, now we don't even need this anymore. So now the processor is just, and later we could of course hide this behind the same kind of macro I'm planning to do here. So have something like this later. Again, I need to process. So have something just to have this at the top, so they don't have to have these either. Unless you of course want to do something in the processor, but it's stereo sample. And well, that's I think I've gone through everything that is needed to actually make a plugin. To install the library, you actually don't need to just download a zip file from GitHub and unzip it somewhere. That's the installation you need. But you also need to have some developer libraries included for OpenGL and X11 if you're using Linux, or probably something different for Windows on Mac. But the Linux, there is not no configuration or something set up or anything you need, so that's very simple to get started. And well, that's it. If someone has any question, I can answer them by. I'm not in GitHub or whatever. Anyway, I think hopefully this was a little bit helpful at least. So until next time.